we use T for the something. The counter, we use a C and 5. See, the T, C, and number is also different. On C5. Now this time we have also have the one timer goes down, one counter goes down, one counter goes up, but not this time. The difference between these two guys is not the same difference between the timer off and timer on. Okay, we want to learn this is the following instructions and CPU. On the CPU, by the way, guys, I send you the link for the survey, and if you have not finished the survey, please finish the survey as soon as possible. And I look at the comments. One comment says that we do not have a big board to write. I'm sorry about that. Okay, because in the middle we need to have a so huge screen, but we can talk with facility, the department, so they can make it bigger or make this guy smaller. Okay, guys, I'm sorry about that, but I will do my best to make sure what I wrote here is accessible to you. This is one comment. And so say CTU, okay, this is the timer, we have learned TON, timer on, and then we have learned TOF, the timer off. So these two guys, they are different, as this is Aiden answered. The difference is that this guy is triggered by force to true, the pulse, force to true, the transition. TOF is triggered by true to false transition. Okay, so we know this difference. But the counter here, we have a CTU, and counter up, and CTD, and CTD counting down. We have these two guys. These are two counters. And the difference between these two guys is different from the difference between timer on and timer off. I'm going to talk about this, and we will learn the move. This is the command or instruction. The move means that we move something, some content, some number, or some other contents from one place to another place. Okay, say move. And the RES, the reset. This is the reset for the counter. And also we'll have reset for the timer as well. So reset is the instruction. And for this reset, whenever you want to add a reset, the instruction, you need to specify the address, right? You need to specify which timer or which counter, and you need to, this is the reset. So this is this objective. The function of counter, as the name suggests, the counter means that they count something. Right? They count something. To count the number of atoms being produced and tested. And maintain the level, for example, maintain the level in a tank by counting the number of gallons pumped in and drained out from the tank. You can just count how many the gallons you have pumped in or just drained out from the tank. And keep track of very long duration timer period by combining a timer and a counter. You can combine a timer and a counter together, okay? A counter, the timer itself is used for the time. The counter, you can just have many counters. This counter is done, and you just start another counter. So as a result, if you combine a counter and a timer together, and you can have a very long duration time. And so by the way, if you are interested, guys, and you can just design a PLC system and to count on how many cars each day enter the compound garage. All this is the how many cars, and each day the exit is this is the garage. So you can use the counter, and whenever the car is enters, this is the garage. The counter is triggered, and then the counter, and they will just have increment by 1. So this is how it works. This counter is the same as the timer in terms of instruction, in terms of this is the starter, okay? So it's also made of 3 word element. And as a timer also has 3 word element. Word 1, word 0, word 1, and word 2. And word 0 is a control word containing the status bits of the instruction. And also this is the same as the timer. So word 1 stores the preset value. It's same also as the timer. And we also, for the timer, we have preset value. And for the counter, we also have a preset value. And preset value specifies the value on which the counter must reach before the controller sets the done bit. You can see this is very similar to the timer. Okay. So when the time is off, and the done bit will be set to set high. Here, if the preset value of counter and also reaches the also is reached, then this controller will set the done bit of the counter and tell people that counting is over and you can do something, control something. So preset and accumulated value and ACC accumulated value, and for here also we from 0 to the preset value. It's the same as the timer. Preset and accumulated values for counters are reached from negative, so this value to this value, and are stored as signed integer. On this sense, this is a signed integer. So second word, the word 2 stores the accumulated value ACC as the same as for the timer. And this is the number of false to true transitions that have occurred since the counter was reset. And you need to know that this is a number of false to true transitions. Right? So counter only counts false to true transitions. If this is the value is true all the time, it will not count. If the value is false all the time, it will not count. Or if the signal changes from true to false, it will not count either. This guy only counts false to true condition. So here is a diagram of these 3 word structure. Word 0, word 1, and word 2. You can see word 1 on preset value. Word 2 is updated automatically by the system. So you can see word 0 and CEO, CD, counter up, counter down, then OV, and U1 and UA. And also there are some bits that are reserved for internal use. So the accessible bits. This accessible bits means that you can visit, you can get the status of this guy. And the counter up enable and counter down enable done bit overflow, the underflow. Underflow means that the number is lower than the minimum value, negative, which is negative. And overflow means that the number is greater than this is bigger or greater, and then this is the upper limit. The UA is updated accumulated value. Okay, updated accumulated value. And HIC is fixed controller only. This is hard, and this is hard. This is the counter, right? So accessible words, and you can just get this preset value. If you want to visit the preset value, and you can just get the preset value. And also you can get the current ACC value. Questions regarding this slide? No question? And then a counter addressing structure. Okay, counter, as I said, this guy is a counter, and you must have address. And the address is a C. We use capital C to denote this counter. if the file number, and usually we use 5, okay? And we use 5, C5 and T4. So this is our convention. And E is element number. We have 3 word elements, and S is a sub element, B is a bit. And you can see for the counter, and you can visit the bit that are available. You can visit the bits, not just the bit, multiple bits. And you can visit some 2 words, preset value and ACC value. So this is the P4 and C5, and keep this in mind. So this how counter works. So one counter has two is the pins, and I will saw the terminals, or it is you can enter the signal. And the counter, one is a counter up and one is counter down. Right? So this is a counter accumulated value. So this is the maximum value beyond this overflow. So this is the minimum value beyond this line in this direction is underflow. So supposedly, and your counter only work from this from here to there for this range. We want to avoid this is either overflow or this underflow. Other question regarding this slide? No question? So count up. So you can count up. The count up instruction that counts false to true wrong transition. I want you guys to underscore if you have access to the PDF I just posted, or you can just write down and draw down using your pen on a piece of paper. False to true. So when the wrong condition for a CPU instruction makes a false to true transition, and the accumulated value is incremented by 1. Right? So this is incremented by 1. The ability of the counter to detect false to true transitions and depends on the speed of the encountering the signal. If the signal, it means that if the signal changes very quickly, and sometimes you will miss the transitions. You understand that? For example, the signal changes very, very quickly, and maybe the built-in counters will not work for you, and you need to have hardware counter. Hardware counter means that you need to pay more money and to buy this hardware counter. So the on and off duration of incoming signal must not be faster than the scan times. That's why 2 times. So otherwise, it will not work very, very well. Just like the stack motor. I told you guys the stack motor, sometimes the steps are missing, right? But here, if the signal changes very quickly, from false to true very quickly, and for some transitions you just miss. Right? But accumulated value is retained when the wrong condition again becomes false. Then after this wrong condition and changes from false to true, and then the ACC value start incrementing again. So this is how the counter up work, CPU work. So there's more insight into CPU status bit. So you can see that this is the 3 bits, the 3 most important bits. And for us, this counter dump bit is very, very important because we usually use the dump bit to control something. The counter up overflow bit and the counter up enable bit. And so this guy, we can this and this one, you can just take a look, okay? And the overflow and when the number accumulated value runs around to this one and continuous counted up from here. So it's set. This one is set if this condition is met. So for here, if the wrong conditions are true, so this guy will be set. A dump bit accumulated value is equal to greater than the preset value. If this condition is met, the dump bit is turned on. Right, so this is how it works. Very similar to this is the timer, TON and TOF. So then we talk about the counter down. You can see the counter down itself is also only count the false to true wrong transition. Understand, guys? Yeah, that means the CTU and the CTD, both of them only count false to true transition. And true to false transition, this guy does not care. Right? So when the run condition for the CTD instruction makes the false to true transition, the accumulated value is decremented by 1 count. So accumulated value is retained when the run conditions again become false. Question so far for this is CTU and CTD. So these two guys, both of these two guys only count the false to true transition. So in this aspect, counter is different from the timer, right? T1 and T5, they are different. And T1 only is triggered by the false to true transition, and T5 is only triggered by true to false transition. That's for timer. But for this counter, and CTU and CTD, both of them are only triggered by false to true transition. So why I emphasize this? Because based on my teaching experience, when I in the quiz 2 or the exam 2, if I ask this question, some students just tell me a counter up only counter false to true transition, counter down only counter true to false transition, and this is wrong. Okay, because it is very very confusing if you do not pay attention. Because for the timer we have this the difference, but for counter no. For counter, both CTU and CTD, they only count false to true transition. But why this one is called up, one is down? Because counter up means if you have one more transition, the ACC increment by 1. Okay? That is why the counter up, going up, ACC going up, not the transition going up. And this is counter down means that if one transition comes, the ACC decrement by 1. That is the reason this guy is called counter down. I want to emphasize, because as I said, based on my teaching experience, some students, they are confused. So this is more insight, and more insight. This bit and this bit can be, and once again, these are the 3 important bits. Counter down and flow for counter up is overflow. The down bit is very important, because we usually use the down bit to control something, and after the counter is off. And counter down enable bit CO and is set when the run conditions are true, and for this set. Right? When run conditions are true means that and you have false to true transition. Questions regarding this is the counter up and counter down? No question. And then we take a look at the move. This is the move instruction. MOV. MOV is also instruction, and this guy will help us to move some content or a number from one location to another location. So move. So you should know that this guy is output instruction. If some conditions are met, and then I'm going to move some value from one location to a second one. Right? But this guy is output instruction. As long as the run remains true and this guy works, the instruction moves the date each scan. These are several parameters. Okay, as I said, for move, we want to move something from one location to another location. So how many parameters should we have? We should have 3, right? First one is which value. Second one is the source destination, the source location. And the third one is the destination location. Do you guys agree? Okay, so source, address, or constant of the data you want to move, right? So this is from the source, and the source is a location. You move this is source, this is content of this source, and then move to the destination, the address where the instruction moves the data. Questions so far? You must have a source location. You must have this is the destination location. Questions? So no questions. We have learned our basic tools: counter down, counter up, and move. And then we are going to use example to illustrate and how we use these three guys. Okay. So this example is here. This example, and we have a conveyor belt. Look at here, and we have a conveyor belt. We have a sensor 1 and a sensor 2. So suppose here is operator number 1. There is operator number 2. What we want to do? A user should be able to select the maximum number of pellets using a selector switch, the first one. All right. So here, from the sensor 1 and sensor 2, I can select here currently the 8. We have 8 pellets. Maybe another student say, Dodema, I don't want to keep 8 pellets. I want to keep 6 pellets. The third student say, Dodema, I want to have the 10 pellets. So first, you must be able to accommodate certain number of pellets. So this is our first task. Second, you must give the users flexibility that you can change how many pellets you want to accommodate between sensor 1 and sensor 2. So this is our 2 requirements, okay? How can we do that? For the first requirement, we count, this is a certain number of pellets there. And we can use a counter down and we can use a counter up. And to make sure for this between sensor 1 and sensor 2, we always have the certain number of pellets. The first one. Second one, and we can use the move instruction to change how many pellets we want to accommodate in the sensor 1 and sensor 2. So that's the reason. And we are going to use this example to illustrate and how we use counter up and counter down, also move, and to accomplish these two goals. So you can see the damped inhibits operation damped here. Inhibits operator number 1 from releasing additional pellets on the conveyor. So we want to have this is a certain number of these pellets between sensor 1 and sensor 2. So here is a ladder diagram, and we are going to do this. I'm sorry, we will not do this, but I'm going to test your understanding of this one. You need to use your own language to interpret on this diagram. Okay. Let's see. You can see. First of all, I'm sorry. So if you have them, so this is a C51. Okay, 1 1. All these guys are counter 1. C5 means counter. And then colon, then the number behind the colon means which counter. And for here, we only have 1 counter, okay? But this one is I copied from the textbook. This type of textbook here is wrong. We have 1 here. Understand? So, but in my PDF file, I changed it. But it is a PPT file because in the PPT file, because this one is I just cropped from the textbook. I cannot change. I just want to let you know. So how it works, guys? How it works? So at the very beginning, okay. At the very beginning, now I want to tell you my expectation when you interpret this how the diagram works. So first, you need to tell me the whole picture on what this diagram does for you. First thing. And second thing, you need to go through round by round to tell me each round does what. This is what my expectation for this case. Okay, for this case, so at the very beginning, the damped the 10 bit is reset. You guys agree? That means at the very beginning, the counter does not work. Counter does not work means that the 10 bit is reset. I'm sorry. It's reset means the low is a false, right? And this guy at the very beginning, this guy low and false. And then we have see here, you can see C51/10 bit. So this 0 has a oblique line. It means that this is the opposite status of this original one. So at the very beginning, this guy is false, then the opposite is true. You guys agree? The opposite is true. You can see if the gate release operator 1, if you this operator number 1, if this guy releases the pellet, and then releases one pellet, so this guy is true, right? True. The solenoid, the gate 1 is true, and solenoid gate 1 is true. That means you can just see the sensor, just the counter counted. This is the sensor 1. The sensor 1 counted, right? So I'm sorry. This solenoid is controlling the conveyor belt. Solenoid controlling the void belt. After the conveyor belt is rotating, when the conveyor belt is rotating, and then the pellet will move from operator 1 to sensor 1, right? And then the sensor 1 detects something. The sensor 1 becomes true, right? And it becomes true. That means this guy changes from false to true. This transition and will trigger on this CTU. Understand, guys? Okay. Will trigger the CTU, and CTU going up, and then the ACC from 0, 1, 2, 3, 4, 5, 6. Until this guy goes to 6, the 10 bit is set. If the 10 bit is set, then the opposite is false. As a result, this solenoid is turned off. Solenoid is controlling this conveyor belt. The conveyor belt will stay there. That makes sense? And for second one, the second sensor, if the second sensor detects something, and then the counter down, okay? Also the same counter, but this is different. This is the terminal, we call terminal, or the CTU. Preset value is also 6, a counter is 0. So this guy is triggered. This guy is triggered. And when this guy detects 6, and then this 10 bit will be be set also. Be careful. This 10 bit and this 10 bit, they are the same 10 bit. Okay? Because we are using the same counter. These two 10 bits, they are the same. So this is a counter up and counter down. Then this is a following. This is the instructions. I can see, as I said at the very beginning, and you can have 6 pellets between 2 sensors, right? And as I said, student B say, I don't want 6, I want 8 pellets. And then you just press this one, then you just move. This is 008 and to the preset value. As I said, this should be 1. You just change the preset value. So the student C say, hey, I don't want the 8 pieces, I want 10 pieces between 2 sensors. And then this guy click this one, and then you just change the preset value. We can, okay? And then the student A say, hey, I want to change it back. We can do this one again. This is how these 3 rounds work. Any questions so far? Can I ask one volunteer and to come here to tell me how this guy works? If you volunteer, I will give you a bigger bonus for the final. Hey, come here.
So like the whole thing, how it works.
The whole thing, and then the one round one by one.
So we have the first run here. It initially can't go through until this is activated. And when you activate this, it can go all the way through, which opens the solenoid, which causes the conveyor belt to move. And then sensor one, when this becomes activated, so when something goes past sensor one, say it's like a block on the conveyor belt goes past, it'll activate this, so this will be energized. So then counter, as soon as it's counter up, the accumulated value will go up one. And will keep going up one until it reaches 6, and when it reaches 6, the done bit will be activated, which will cause this to open, which means that this was no longer, it can't flow through the first rung anymore. And then on the third rung, you have sensor 2. So when something passes sensor 2, it activates the counter down. So the accumulated value, say if it was 5, will go from 5 to 4. And on the fourth rung here, if this is activated, it'll change the preset value of the counter C51 to either 6, 8, or 10, depending on which one of these you press. So if you press the one here, this will be energized, so that move output will activate, so it'll change the preset value here and here from 6 to 8. And same thing with this, if you press this button, it'll change it to 10. If you press this, it'll change back to 6.
Wonderful. This is round by round. What is the whole picture of this guy?
The whole picture?
Yeah.
It's controlling.
Yeah, to facilitate your explanations, I'm
Yeah.
going to give you show the first one.
It's controlling
Yeah.
this conveyor belt.
Yeah.
So
What goal or goals we want to accomplish?
the goal is so that you have a specified number of like boxes between sensors 1 and 2.
Yeah, wonderful.
Yeah.
Thank you, Eden. Thank you very much. Last name?
Martin?
Martin.
Yes.
We have another Eden, right? What's your name? Last name?
Bird.
You also Eden, right?
Yeah.
Eden Martin, right?
Yes.
Okay, I will write down. This is a wonderful explanation.
Um,
Ethan, what's your name?
Hayden.
Hayden, okay. Hayden.
For CTU and CTD.
Yeah.
Are those changing the same counter or do those have two different counters?
Same counter.
Okay.
Yeah, each counter has 2, CPU, CTD.
Okay.
It depends on how you wear them.
Mhm.
Not where, I should not say where, because how you connect them using the ladder diagram.
Okay.
Not hardware, no, you do not physically wear them.
Mhm.
But you just specify them in the ladder diagram.
Okay.
Good question. Any questions, guys, regarding this one? If you have questions, either ask me or ask Eden. Thank you, Eden. Thank you very much. So this one, as I said, this one will be tested, okay, in our either quiz 1, quiz 2, or exam 2. So if you do not have questions regarding the CPU, CTD, and this diagram, and then we are going to talk about our the tasks for our next lab to be carried out on Monday. So what we are going to do, we have 2 tasks. On first one, and we are going to accomplish this start, stop, seal in circuit using PLC. Read my lips, guys. Using PLC, right? And last time we accomplished our goal of start, stop, seal in circuit and using hardware. But now this time we are going to accomplish this goal using the PLC. If we want to use the PLC, and we need to have the PLC lessons. So I'm going to test the PLC lessons today. I'll make sure all these licenses are working on these 6 stations. All right. So that's the reason I want to postpone our level 2 to next Monday. Also give you more time to finish the level 1 report. So as I said, okay, so this green light. So if we start this one, if we click this start button, and this the green light will be turned on and will remain on until you click this stop button. However, as I said, I told you a couple times, I think, okay. And for this PLC, the stop button, right? is a stop button, and they are normally closed. That means when you write a ladder diagram in the PLC, so here you should not use this oblique line, right? If you use the oblique line, it will give you this one will be running very crazy. As I said, because in this convention, in PLC world and in the control relay world, the stop button is manufactured differently. The stop button is always normally closed. Until you press it, it will be open. Open means force. The water cannot go flow. You understand, guys? Okay, so this is our first task. How to do that, guys? And you need to wear the start button and to the PLC, stop button to the PLC, green light to the PLC. All right? So they are not physically connected. So input instructions are connected to the input module of PLC. I want you guys to write down, because this is a very distinct difference between this circuit and the hardware circuit we tested last time, right? Hardware circuit, you need to use the wires to wear everything. But here, the input instruction, these two input instructions, and will be connected to the input module of the PLC. So this output instruction will be connected to the output module of PLC. So output instruction and the input instructions, they are not connected physically, but they are connected to the PLC. This is why I emphasize that, because still based on my teaching experience, and some students, they are confused, and they still want to wear all these guys together using the physical wire, the hardware. So this is our first one. And second one, this is a hardware timer logic. So this is hardware, okay? So this hardware means that, and we are going to wear them using the wires. So we have stop button, right? Stop button. And this timer is a hardware timer. This is not the PLC timer, the hardware timer. I'm going to show you the hardware timer, okay? So this is the let's see, the red light, right? Red light, this red light, and this green button. If you click the green button, the timer and should be energized, right? Should be energized. And if timer is energized, the green light is on. And when the timer is off, when the timer goes off, and then so this guy and will be turned off. So at the very beginning, the timer is off. I'm sorry, I should not say timer is off. At the very beginning, so this guy is a false. You guys agree? At the very beginning, this guy is a false. So oblique is a true. So this stop is always normally closed. Okay, so water can go through. So at the very beginning, the red light is turned on. But after you click the green button, the timer starts. Then after some time, this timer is set high. Okay? Timer is set high. As a result, this oblique is false. The red light is turned off. But when this guy is set high, so this is high, and the green light will be turned on. So this is how this diagram works. So here is a timer. So this is the hardware timer. The hardware timer, you can see, and we need to have. Can you see clearly? So we have terminal. This is the terminal. Okay. What it is? Can you see, guys? So this is a red one. So this is a dark one. So we have power here, and we have the ground here or common here. You need to energize it, right? And then, so here is a timer, right? So you can just adjust how long the preset value. We use the word preset value you want.